scientists just broke the laws of physics. They created a solar panel that produces 130% efficiency, generates more energy than it receives from the sun itself. For over a century, we've been told that solar panels can never exceed 100% efficiency. It's basic physics. You can't get more energy out than you put in. That's the Shockley-Queisser limit, the theoretical maximum that has constrained solar technology since the 1960s. But 3 weeks ago, a team at MIT published results that obliterate this fundamental barrier. They didn't just break it, they shattered it by 30%, and what they discovered could completely rewrite our understanding of energy itself. But here's what nobody's talking about. This breakthrough might actually prove that nuclear fusion has been looking in the wrong direction for 60 years. To understand how impossible this is, imagine trying to fill a bucket with water, but somehow ending up with more water than you poured in. That's essentially what these scientists achieved with light and energy. The process they discovered is called singlet fission, and it involves splitting one photon of light into multiple energy carriers called excitons. Normally, when sunlight hits a solar cell, each photon can only knock loose one electron. One photon equals 1 unit of electricity. But these researchers found a way to make one photon generate multiple electrons. It's like splitting an atom, but instead of nuclear fusion, they're doing photon multiplication. The implications are staggering. Every solar panel on Earth could theoretically become 30% more powerful overnight. The global energy crisis could end not in decades, but in years. But there's a catch that could change everything. The materials required for this breakthrough are what scientists call spin-flip metal complexes. Sounds boring, right? Wrong. These are some of the rarest and most expensive compounds on Earth. We're talking about elements that make platinum look cheap. The research team used materials that currently cost more per gram than weapons-grade uranium. Scale this up to power a single city, and you're looking at an infrastructure investment that dwarfs the entire Manhattan. Project? But here's where it gets really crazy. The same rare earth elements needed for these super efficient solar panels are the exact same materials that fusion reactors need for their magnetic containment fields. We're not just talking about competing technologies anymore. We're talking about a resource war that could determine the future of human civilization. And China already controls 90% of the global supply. But the real bombshell isn't the efficiency or the cost, it's the timeline. Fusion researchers have been promising 20 years away for the past 60 years. They're still building ITER, a $35 billion fusion reactor that won't even produce net energy until 2040. Meanwhile, these solar breakthrough researchers claim they can have commercial panels ready for mass production by 2027. 3 years, not 3 decades. If they're right, fusion becomes obsolete. Before it even gets started, the trillion-dollar fusion industry would collapse overnight. Entire nations have bet their energy, futures on fusion technology. But what if the real clean energy revolution isn't happening in massive tokamak reactors? What if it's happening in something you could hold in your hands?